I have been given a very, very difficult task today, because within half an hour I have to complete about a portion which constitute about 70% of the research. Why? Because sampling and questionnaire design. Now, by means of sampling, I will be very, very concise. What is the meaning of sampling, and what is the meaning of population, and the relevant terms in a very straight way. Well, first of all, and the discussion will be mainly, from the practical point of view rather than the theory, and what we actually do while we actually go for the sampling part, right? So we will be going to discuss mainly about that. Now, why we are saying that it is constituting about 60 to 70% of the entire research work? Because the sampling constitute raw material of the research. No matter how good a cook you are, but if your raw material for for making the dish is not up to the mark, or it is wrong, then the output of the dish cannot be used effectively. Okay. So by saying that, let us go straight away to the presentation and see that what actually the relevant terms of the sampling mean, and how actually we go for sampling of different things. Okay, I hope the presentation is clear, right? Is it which is visible to everybody?
Yes, sir.
Okay, you see, first we will come to our learning objectives, learning outcomes. After the session, what are the things that you will come to know, and what are the things we are going to discuss? The first is the concept of population and sample. Then the second one is the type of the sampling method. What are the different sampling methods that you will going to use, and why? Next is the selecting the random samples from sampling frames using MS Excel. And the last one is the sample size determination. So these are the outcomes that you will be mainly getting out from these particular lecture session. Okay. Now we are coming to the process. So what are the sequences that we will going to follow while designing a sample? Right? What are the sequences we are going to follow? But before we go to that slide, let me make it very clear that sampling is an very, very important part of primary research. Whenever you are doing a research using primary data, or whenever you are doing a research, call it empirical research, then we have to use sampling. It is indispensable for those type of researches. We will follow during the sampling process. Now, the first part of the sampling design process will be, to define the population. First, you have to define the population. Now, what is your population? The population is the entire set of units from which you want to draw the information, and you want to, give inference from your study. The entire one. Suppose, if I am talking about, say, that how many smokers are there, right, in some part of Odisha, maybe in Bhubaneswar, then all the people living in Bhubaneswar will be my population. All the people. We cannot leave out a single person. Right? So that is my population, and I want to take information from each one of them, that whether they are smoker or they are non-smoker. Right? And then we will draw an inference that what is the proportion of people living in Bhubaneswar are smokers or not. Right? How many people are actually smokers, how many are not smokers and all. So we have to, take information from all the units present in Bhubaneswar. Now comes the sampling frame. Now there are some cases, or in most of the cases when we will be, or we are actually going for the social science research, we find the population is not finite enough, so that we can, take all the person from there, or all the people, or all the units are not accessible. So what we do generally is that we actually make the population in size, we call it the sampling frame. The other name of this is the effective population. So sampling frame is the effective population. It is in the form of a list from where we will going to take the sample. Now, what is a sample? Sample is the subset of the population. Now, what is a subset of the population? We will be taking some units out from the entire population. We cannot take all the units present in the population because of the time constraint, because of the cost. We cannot reach to each and everybody, right? So there are other factors as well, but these three are the major factors: the accessibility, we cannot reach them properly. Number one. Number two, the cost is very high, right? If we want to cover everybody. And number three, the is very high, right? So, and in the research, the result might change. So we have to take sample, but the only criteria is that the sample must be the representative of the population. It must be the true representative of the population. So what would we do to collect the sample so that it will be a true representative? We will come to it later. So defining the population, determining the sample frame, selecting sampling techniques. Now there are several methods by which we can select the sample out from the sampling frame. There are scientific methods or the probabilistic method. There are non-probabilistic methods as well. And it will depend on the nature of the population. It will depend on the nature of the study that we are going. It will depend on the sample units that we are collecting. That what technique we will going to choose. Then we have to determine the sample size. Now, believe me, this is $1 million question. What sample size I will going to use so that my research will be unbiased, so that my research will be effective. So again, there are several ways by which we can do that. Several ways by which we can do that. We will come to it later, right? And then we can execute the sampling process. Now, remember one thing: if your target population is wrong, then your sampling frame will be wrong, your sample techniques will be wrong, your sample size will be wrong, and executing the sample process will be wrong. Your sample will be wrong, so your hypothesis will be wrong, your analysis will be wrong, your result will be wrong. Now I think I'm clear why I told you that sampling process occupies 70% to 80% of your entire research. No matter how good a statistician you are, no matter how effectively you can use your SPSS, R, or Python, but if your sampling is wrong, everything will be wrong. Okay. Let's come to the target population. The target population is what? It is basically the collection of elements or the collection of objects that causes the information sought by the researcher. Whatever information I actually need as a researcher, I can get it from the collection of the elements, and those elements are known as the population. And we have to draw inferences. Okay, we are talking about hypothesis, we are talking about estimation, we are talking about parametric and non-parametric tests, but what are they used for? What is the usefulness of these terms? These terms are actually used to draw inference on the particular population. So how a target population is defined? Target population is defined in terms of the element. What is the element? Element is the object about which or from which the information is desired. Here the element may be the respondent, the element may be something else as well. What is a sampling unit? The unit from the population which is available for selection. That is called the sampling unit. What is the extent? It is the geographical boundaries. If we are doing research in Indian context, the result will be different. If we are doing research in Japanese context, result will be different. And if we are doing research from US or UK context, definitely the result will be completely different, right? Because the respondents are different, and their the sample is different, and geographical boundaries are different. So there are several factors which actually affect the output. Time is also very, very important, as you know that in social science. If you are doing a research now and if you are doing a research tomorrow, the things might be changed. So these are the four elements you have to remember, while defining your target population. And if you can define these four elements properly, then your population will be well defined. Next, we are coming to the sample frame, because these are the relevant things, as I told you need to know. It is a representation of the elements of the target population. For example, if we are trying to find out that how many what is the total population of the city of Bhubaneswar or total population of the city of Kolkata, then instead of going house by house to know that how many people are living over there, we can use a telephone directory, right? Again, you can say that sir, many people don't use telephone directory. That's fine, but the number of people who are actually using the telephone directory is enough for you to draw sample from them, right? So sampling frame is another thing which we call effective population, not the entire population, not the exhaustive population, but the effective population. Next, you again to the sampling. Now, I told you that sampling, it is a process by which we draw the units from the population, and we actually do our analysis on the sampling units, and then draw the inference on the population by means of a process which is called hypothesis testing. But sampling can be done in what is a with sampling or without sampling. What is with sampling? With replacement, without replacement. What is with replacement? Suppose you are taking a unit out from the population, and after recording the information from that unit, you are returning it back to the population. So you are replacing it. And what is without replacement? Without replacement means you are taking a unit from the population, right? And after taking the information, you are not returning it back from the back to the population. So that in your sample, that person will not be repeated, or that unit will not be repeated again. So if you want repeated respondents in your sample, you can use sampling with replacement. If you don't want it, you can use without replacement. I will not replace the person from whom I have taken the information. And what is the sample size? Sample size is the number of elements to be included in your study. Now, you see, why I am telling sample size is important, because the first criteria that I told you is that the sample must be a true representative of the population. Now, if you increase your sample size, definitely what will happen? The precision or the error component is going to decrease. And obviously, your the true value of the population will be more effective. Okay, but again, there should be a balance between the sample sizes. If it is too low, then it will be difficult. If it is too high, then also it will be difficult, because then a lot of non-sampling error may creep into your system. Okay. Now let us come to the as I told you, these are the different sampling frame. You have to understand the sampling frame very well, because you have to define the population. After defining the population, in most of the cases, you will find that you don't know where to take the sample from, right? So you have to first convert or transform your population into your sampling frame, which is in the form of list, right? Total list, random digit dialing, telephone book. These are all examples of sampling frame. And it is very much essential for the probability sampling. Now let's come to the probability sampling very first. The types of sampling that we are using over here. You see, first we are dividing the sampling into two parts. One is the probability sampling, one is the non-probability sampling. But first, try to classify. Let us try to classify how we can classify these two sampling methods. What is the parameter by which we can classify between these two methods? The first method is that, suppose there are 10 respondents in a population, okay, and I want to select 5 of them. Now, whom to select? That is very important thing. Whom I will going to select. Now, if I don't know that which person will be selected in my sample, that will be the example of probability sampling. That means randomly I will going to select my samples. So why the name probability? Because each one of the units of the population has equal probability of getting selected or deselected. And that is the reason why it is called the probability sampling method. Non-probability sampling method. Well, if you are talking about non-probability sampling, you can say that here equal probability is not assigned. Rather, it is dependent on researchers' discretion. So obviously, some amount of bias will creep into this system. But in case of probability sampling, no type of bias will be getting into the system. So what type of study will support probability sampling method? What type of study will support non-probability sampling methods? If you are going for exploratory study, I'm not defining these terms, I hope you know that. If you are going for exploratory study where you will be constructing the hypothesis rather testing it, you will be constructing the hypothesis, framing the hypothesis, then non-probability sampling method can be used. Even if you are going for a pilot study, right, or for the pre-testing of your questionnaire or something, you can go for the non-probability sampling method. Or suppose if you are doing a research on a very complex topic, which is definitely not into the knowledge of a common people, you may go for the non-probability sampling method. Suppose I am doing a study on space physics, right? Or if I'm doing a study on astrophysics. Now these are the things which only the specialists can give me proper information, but non-specialist will have no idea about it. Now, if I take information from the non-specialist, definitely my information will be wrong, my analysis will be wrong, my output will be wrong in that manner. So in that case, I will be only selecting those person, who actually know the particular topic. And from my knowledge, I will going to decide that this person will going to give me a better result, better information, or the other person will going to give me a better information or the better result. This is non-probability sampling technique. Now I will give you another example so that you can better understand it. Suppose there is a mixture of students in terms of background. There are science students, commerce students, art students, management students. So there are different type of students who are sitting there, and I am taking a class on statistics. And after the end of the class, I am randomly picking up students and asking that whether they have understood or not, whether my content is effective or not. Definitely, the people who belong to the arts background, right, they will say that I have not understood anything. Even if my content is good, even if my explanation is good, but the arts background people will not understand that. And when I'm drawing the sample from the population randomly, and unfortunately, if all the arts and the commerce student they are coming into the sample, so definitely they will give me a result which is highly biased. So in that case, what I will do, I know that only I will going to ask the science students that whether they have understood the concept. I will going to ask the art students that whether, whatever they have learned before, whether some knowledge is being added to their system or not, that I can do. So, if there is a mixture of group, I will not go for anything else rather than the quota sampling here. What is quota sampling? I am forming the quota. Science people are one quota, commerce people are one quota, arts people are one quota. So these are the different type of quota systems. And from this quota, I will be selecting, according to my judgment. Okay. Convenience sampling. It is the most simplest form of sampling. Right? Convenience sampling is the most simplest form of sampling. But remember one thing, you can never use convenience sampling if you are doing a descriptive type of research design or a causal type of research design. Never ever use the convenience sampling. You will not get a proper result for that. And snowball sampling. Snowball means, if there is a snowball and if you are throwing another snowball to it, the snowball size will going to increase, right? So this is basically the network sampling. Suppose, I have gone to a particular hospital or a drug addict, right? So, the research that I am doing is highly touchy, right? So if I cannot just ask everybody that whether you are a drug addict, you are a drug addict, you are a drug addict, I cannot use these terms to everybody. So I know that a person is a drug addict. I went to him, and from that person, I can get the information that other drug addicts, and if he is referring me to that particular person, so that particular person will be confident enough to give the information. Right. So snowball sampling is the other way of sampling. But now come to the most vital part of the sampling, which is known as the probability sampling method. I'm going very fast, and then I will be opening the Excel to show you how these things are actually done. Now, the first thing is the simple random sampling. Now, what is simple random sampling? The name itself suggests that blindly you select the sample units from the population, right? There will be no pattern, there will be no information beforehand that I will be selecting that particular person, no, right? So you will be selecting randomly from your population unit. Now you see, while you are selecting randomly from the population unit, again, whatever I told you before, that you can take a person, take the information, return him back to the population, again take the same person in the process of randomization. So if you're doing that, that is called simple random sampling with replacement. But if you are not doing that, then it is called simple random sampling without replacement. Okay. Next, come to the most vital part, which is called the systematic sampling. Systematic sampling means what? This is a complex process, basically. What is that? Suppose you have 100 population. The population size is 100, and you want to take 10 sample out from that 100. I repeat once again, you have your population size is 100, okay, and you have to select 10 out of these 100 population as a sample. So what you will do, you first divide 100 by 10 and you will be getting 10 as the number. So this 10 is known as the A. This 10 is known as the A. So here every 10th element needs to be selected. Okay, needs to be selected. So out of this 100, from 1 to 10, you select any number. From 1 to 10, you select any number. Suppose you have selected 7 from 1 to 10. And you have a list which consists of 1 to 100. So the first number you have selected and randomly. And from the first number, the 7th respondent will be selected from the list. And then comes 7 plus 10, that is the 17th respondent. Then comes 17 plus 10, 27th respondent. Then come 27 plus 10, 37th respondent. And in this manner, you can take 10 respondents out from the 100 respondents. Here there is an example. For example, there are 1 lakh elements are there in the population when we have to take a sample of 1,000. So what they have done, they have just divided this by 1,000, and 100 is I means the interval from which I will going to select the unit. Now a random number between 1 and 100 is selected. That you have to select randomly. Whatever is coming to your mind, you can take the help of a table or whatever. Now if, for example, this number is 23, then the sample consists of the elements of 23, 123, 223, 323, 423, 523, and so on. This is called systematic random sampling. Okay. Next, let us come to the stratified sampling. What is stratified sampling? Well, as I told you, that stratified sampling, in case of quota sampling, like in quota sampling, you are divided into different groups, and from the groups, you are separately doing the sampling, right? You are not, individually or randomly you are selecting from the population. Rather, the entire population is divided into different groups or different levels, and these groups, if you add, you will get the entire population. Okay. So what will be the nature of the group? The nature of the group, it will be mutually exclusive and mutually exhaustive. What is the meaning of that? That means the group must differ from each other. The group must differ from each other, but within the group, it has to be homogeneous. Within the group, whatever elements are present, the characteristics of those elements must be homogeneous, must be similar. But between the groups, it has to be highly heterogeneous. If that is the case, then we can go for the stratified sampling. Rule of thumb says, actually, while doing different research studies, what we have identified or observed is that try to maintain 2 or 3 groups. Don't go more than that, because then it will create confusion, it will create complexity more. And regarding the variables, or regarding the size, you can take maximum of 6. Don't go beyond that. Then again, it will create the difficulty. And the stratified random sampling, whenever you have created the strata or you have created the group, from the individual strata, the sample units has to be selected randomly. And that is why it is under the group of probability sampling. Okay, I hope it is clear. So if the question is what is the difference between quota quota sampling and stratified sampling, in both the cases, we are actually forming mutually exclusive and exhaustive groups. But in case of quota sampling, from different quota, we are selecting by sample units by means of judgment. But here, from individual strata, we are selecting, respondents by means of randomly, by means of random sampling. Again, this stratified sampling, this can be divided into two parts. The first part is, it can be proportional stratified sampling, or it can be disproportional stratified sampling. Mainly we use the proportional one, but why disproportional is coming is that, if you have huge difference in terms of standard deviation within the groups, then, the proportional stratified sampling will not be used. There we will go for the, disproportionate stratified sampling. Then again, the sample size which we will be actually taking from individual strata will definitely going to differ. Now let us see what are these things and how the calculations is being done. In case of the proportional stratified sampling, suppose I am selecting the ith strata, so which is Ni is equal to N. And what is N? This N means the total sample size from all the strata. What is this Ni? This Ni is the total population of the strata. And what is this N1, N2? This is the total population size of all the strata. So how can we do that? Ni is equal to N into Ni. Ni means the the population size of the strata divided by the entire population of all the strata. And in case of disproportionate stratified sampling, it is very clear that we are inserting a particular over here, that this term is the standard deviation. So we have to calculate the standard deviation of the individual strata, and then only we can find out the sample size or the disproportionate stratified sampling. So disproportionate, sample size will be actually there. Okay. Now come to the last part, that is the cluster sampling. What is cluster sampling and how this cluster sampling is actually being done? You see, what's a cluster basically? A cluster is a collection of all the samples. For example, if we are talking about a school, it is a cluster of students. If our students are, the respondents or the students are the sample units, then, the cluster is consisting of the collection of the students as such. Suppose we are doing a research and where we need a national level sampling, right? National level sampling. So first we have to identify that how many states are there or how many regions are there. If we are talking about India as a whole, then first we have to classify India into different regions. So northeast is a region, west is a region, south is a region, and in this south, if we are moving down to south, then within the south region, how many states are there, right? Then we are selecting the states from there, and the output of my selection will give me certain states. Then we are entering into that particular state to find out how many districts are there. Right. So this is basically the cluster sampling, where I'm selecting the cluster, and from the cluster I am coming out with some output, and again I'm selecting these individual clusters and from the output, and then again I'm selecting the cluster. In this way, until and unless I am reaching my sample unit, I actually go on doing that. Right. This is sometimes known as multi-stage sampling. Why? Because this is not a single stage sampling, but there is a sample frame is there, and I'm selecting the sample units from there. Rather, the sample frames are nothing but individual clusters. So these clusters are selected, of course, randomly, and then we are entering into the cluster, and then again I'm selecting, things randomly. So things are done in that particular manner. This is basically the clustering, which is actually being done. Okay. And if the clusters happen to be some geographic subdivisions, in that case, the cluster sampling is known as the area cluster. All other features remain the same. Okay. Now let us very quickly, whatever we have said, very quickly let us come to the practical part because time is running out. Now let us come to the
No, sir, just a minute. We can extend up to 15 minutes more, sir. We'd love to hear from you. Yeah.
Thank you so much. Okay. Because I need it actually because I have not even completed 40% of it.
Yes, sir, go on, no problem.
Now see, let us first come to this particular Excel. I hope it is visible. Well, first it is the serial number, right? This is an example of a sample frame. This is an example of a sample frame. You see, previously when we don't know much working of Excel, we don't know much working of SPSS, not working of R and Python and other softwares, we used to have random number tables, right? These random number tables and a keyword table. There are so many tables there, which is still now available in Google. You can download it and you can do it. But believe me, it is a very tedious process, right? So what we actually do in real life, in our research process, if you are a PhD student, MPhil student, you can also follow this. If you are a professional in research, then you have to follow this because you will be, handling huge amount of data, right? And you cannot do that manually. This is very, very important. So you see, serial number, why I'm picking serial number? Because it is a list and these are the names. So I've just taken the alphabet as the name and I have 30 population or, sample frame. And from this 30 sample frame, suppose I want to select 10 samples randomly, right? I want to select 10% or 10% from here, A, B, C, D, E, F, G, randomly. So what I will do, I need some random number, obviously, and these random numbers, based on these random numbers, I will going to select the sample. So let's see the technique. Here I have used two things. So first is the SRS WOR, means without replacement, there will be no repetition. SRS WR may be with the repetition. Now that again depends on the random number. If the random number permits, I can go for the repetition. I don't have any problem. But if the random number don't permit, then it will be similar to SRS WOR. Okay, so with the help of Excel, let us see how things are done. So first, I will try to do SRS WOR, that is without replacement. So here, I am writing RN underscore OR. Now this stands for random number with replacement. So uh, no repetition will be there. But suppose the random number is a repetition, I will going to avoid that. Okay. So let us see how can we generate random number in Excel. First you write is equal to, when you write rand, RAND, bracket open, bracket close. Now what is this function used for? This function is actually used to generate random numbers between 0 and 1. Okay, so it will generate random number between 0 and 1, and if I press enter, see it has generated a number, and where from this number came from, we don't know, right? That is why it is random number. And I want to fill the random number, throughout these 30 respondents, so that individual name consists of individual random numbers. So let us do that. I'm just drawing it by means of a fill handle, and I got this. So some numbers have occupied this particular cell. I don't know from where this number came. I don't know, how these numbers are originated. So there is no formula for, originating this number. I can still randomize it. How? After doing this, you press F9. If you press F9, you just, carefully look at this column, Rn underscore OR. See, automatically the values are changing. And which values are coming? Again, I don't know. And since I don't know, that is why it is random. Okay. Now, if it constantly goes on changing like this, it will be difficult, it will be confusing. So let us, stop changing these numbers, right? Whatever, I will be doing, automatically these numbers will change. So see how we are fixing these numbers. How we are fixing these numbers, let us see this. I'm just selecting this 30. I'm sorry. Just select from here. Okay. So let us select this entire thing. Still, if I press F9, automatically it is changing. Now right click, copy, and you paste it in the same region, but you go for paste special. Don't go for paste general option. paste special and go for paste values and click and press enter. Now you press any function key in your keyboard. These numbers are fixed and these numbers will not going to change. Okay. Now see what I will going to do. You select this serial number, name, random number, and you select this total. Okay. So I've selected the entire table now. You go to data and go to sort. From this sort, sort by, you go to random number without replacement, smallest to largest, and click OK. Now see, automatically you need to select how much? You need to select 10 people from this 30 list of 30 people. So you see, you can select these 10. And whom are you selecting? You are selecting 14th respondent, you are selecting the 4th respondent, you are selecting the 9th respondent. Now the question is, previously, but beforehand, we don't know that from this serial number, whom to select and whom not to select, or whom will be actually getting selected. We don't know that. So we will be selecting these 10 people from here. We are copying it and let me paste it over here. So these are the 10 people I have selected, and how I have selected? Of course, I have selected randomly. I have selected randomly. Okay. Now you see, now you have to write the names also, right? You have to write the names, and if your sample is 100, 200, 300, then it will be very difficult for you to identify the names, attached to individual sample units, right? So there is also a way by which I can automatically fill up these numbers with their name. And what is that? That is called Vlookup. Okay, Vlookup or vertical lookup function. See what I'm doing over here. I'm writing is equal to, and then I'm writing Vlookup, and I'm starting with a bracket. First, I will going to give the value of Vlookup. What will be the value of Vlookup? This is the value of the Vlookup, OH, comma. Then I have to take the table from here. Okay. So I have to take the table. So I've taken the table from here. So the table value is there. But you see, one thing you have to understand, that this is a relative reference that you are using over here. You have to make it absolute reference. What is absolute reference? Just above the cell number, just before the cell number, add a dollar sign, so that this dollar will remain fixed. Again, in the P, you add another dollar. And then from what column you will be extracting the name? The column index is 2. Means in the table there are two columns. One is 1, one is 2. And in the second column you are having the name, and you are asking Excel to pick up the name from the second column. So you write here 2. And finally you want the exact match. This is very important. So you want the exact match. You don't want the approximate match. So you write here false. Okay. So right here false, and you see if I press enter, automatically N is coming. You see 14 serial number with the name N. Now what I will do, I will just simply drag it like this, and automatically the names are filled up. So if you have 100 respondents also, no problem, right? You just randomly do that and you select by means of like names. So the names are automatically filled up, you don't have to do anything. Okay. Now you select, now you want to go for the simple random sampling with replacement. Okay. With replacement means there may or may not be, right? That I don't know. If the random number allows, then we will going to select the respondent again and again. Random number don't allow, we will not do it. Let me see how can we do it. Again, I am selecting a new column where I am writing RN underscore with replacement to WR. That is without replacement, with replacement. Here I will not going to create a random number between 0 and 1. Rather, I will going to create a random number which starts from 1 till the end of the population, that is 30. So see what I am doing here. Is equal to random between a different, completely a different function I'm writing here, rand between. Here you will be writing 1, from 1 I will be starting up till 30, then enter. 24, okay, automatically came. Now you just take the fill handle and drag it down 31. See, previously there was 24, now it is 28. So whenever I will do anything, it will going to change. And if you press F9, you see automatically what is happening? Automatically the numbers are changing. Automatically the numbers are changing. Okay. Now let us keep up to this. You select copy, paste spatial and values. Okay. So now let us select 10 respondents. Okay, you see, here I will not going to select the respondents from serial number, rather I will going to select the respondents from the random number, because it will make no difference. You can select it from the serial number, you can also select it from the random number, because serial number is also randomized, the random number column is also randomized, so it will make no difference. So let us select it. Okay, so you take this and put it. Now I see 28 and 20, there is one repetition, that is 28 is coming twice, there is one repetition, 28 is coming twice. Now let us see how again I will going to write the name. You copy the name column, total copy the name column, cut over here and insert the copy insert. So I have taken the name column, again I have taken it over here, and I will be using the same technique that I have used before, that is the vertical lookup. So is equal to Vlookup. Now you select this. Okay, then you write one comma and then you take the table. Okay, so I have taken the table, comma. Now I will write 2 over here once again due to the similar reason, and I will make it absolute reference, so I keep it dollar, and a similar thing I will keep it over here, and here I will write false. Okay, I press enter. So when I press enter, automatically you will see in has appeared. Okay, so name is in. Now what we will do, we will just stretch it like this. So you see here A has appeared 2 times. So here A has appeared 2 times automatically. So I have selected the sample, right? I have no problem with that. Only the thing is that the one respondent appeared twice, and since it is a with replacement, it is actually allowed. Okay, so this is the way by which I can select the sample units with replacement and without replacement. The first process, no repetition. Second process, maybe repetition, but it may be allowable in terms of my research. Now coming to the systematic random sampling. Now see how the systematic random sampling can be used. Now, when I will be going for the simple systematic random sampling, let us go to the original part. How to go to the original part? Just select data, go to sort. From here you select serial number and press OK. So we have whatever sampling frame we have previously, we have returned to that sampling frame over here. So it starts from 1 to 30 and the names are also arranged in that manner. And systematic random sampling. Now here you add a column called mod. Now what means the modulus value? What is the modulus value? Suppose you are dividing 8 with 4. So how much remainder you are getting? getting as 0. So the remainder you will be getting as 0. This is basically the mod value that you are using. Okay, so now how I will going to select this mod? See, so first you select the interval. So how many sample you need? You need 10 sample. What is the population size? The population size is 30. So if you divide it, you will get 3. So your interval will be completely 3. So what you will do over here, you just write is equal to, and with 1, write here 1, write here first mod. Write here mod, then you start with this one, sorry, A2, and your divisor is 3, you are dividing by 3 because your interval is 3, and you press it. So 1 is coming over here, and then you just drag it like this. So again, numbers has appeared in the column, but it is not a random number, mind you, because I know that why this number has come. Now you see what you will going to do in this model. You select the table. You select the table and go to data, go to sort, select mod from here, and again smallest to largest, you click OK. Now you see, the sample size was how much? 10. The population size was 30. So 30 divided by 10 is how much? 3. So I have selected the third sample, 6th sample, 9th sample, 12th sample, 15th sample, 18th sample, 21st sample. So see, if I start from 3, it is, and I take 10 samples, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You see, this is the sample unit that I have selected. Okay, this is the sample unit that I have selected. And obviously, I have selected like that. Suppose I have started from 1. So from 1 to 3, randomly I have to select a number, as I told you, right? So, if I start randomly, we have selected 3. So this is your sample. If you have randomly selected 1, then this is your sample. This is your sample. If you have randomly selected 1, and if you have randomly selected 2, this is your sample. Clear? So, systematic sampling, we don't have to do anything. Just you utilize the mod function over here and just you sort it in ascending order. Automatically, you will get the sample units. Next, you use the same process.